In this video, we're going to talk about classifying differential equations. Before solving a differential equation, it's important to first identify its type, order, and whether it's linear or nonlinear, since these characteristics determine which solution method to use. We'll focus on how to recognize these features and work through some example problems so that you'll know exactly how to classify a differential equation. Let's get started. A differential equation is classified based on its type, order, and linearity. Let's start with type. There are two types of differential equations: an ordinary differential equation called an ODE and a partial differential equation that's called a PDE. An ordinary differential equation contains one independent variable and it has ordinary derivatives. Let's look at two examples. The first example is the derivative of u with respect to t is equal to 6u. T is the independent variable. That's just the variable that you differentiate with respect to. U is the dependent variable, and that's your unknown variable that you're going to be solving for. Let's look at the second example. In this example, x is the independent variable. You have a second derivative with respect to x and a first derivative with respect to x. And then v is the dependent variable that you need to find. A partial differential equation contains two or more independent variables, and it has partial derivatives. Remember that you can recognize a partial derivative by this sign right there. In this first example, t and x are the independent variables, and then u is the dependent variable that you need to find. In the second example, x and y are the independent variables, and v is the dependent variable. Let's now talk about order. A differential equation is classified based on its order. The order of a differential equation is just the highest order derivative that occurs in the equation. Just as a review, a first order derivative can be written like this or this, and then a second order derivative is written like this or like this. Down here, I put three examples, and we're going to go through each one and determine the order of the equation. This first equation has a first order derivative, so it is a first order differential equation. Let's look at our second example. The highest order derivative in this example is d squared y dx squared. That is a second derivative. So this equation is a second order equation. Let's now look at our last one. The highest order derivative in this equation is y prime. That is a first order derivative. So this equation is just like the first one, and it is a first order equation. Now let's talk about linearity. Linearity is just the mathematical structure of the equation, either linear or nonlinear. A differential equation is called a linear differential equation if the dependent variable and all its derivatives are only raised to the first power, they're not multiplied together, and they're not inside nonlinear functions. Let me give you some examples so you can understand exactly what this means. If you have a linear differential equation, it is not going to contain any of these terms. It can't contain a term such as y squared because y is the dependent variable and it's raised to the power of 2. You also can't have a derivative raised to a power other than 1. And in a similar way, you can't have the dependent variable multiplied by a derivative. And then lastly, you can't have a term such as sine y because that is a nonlinear term and the dependent variable is inside that function. I've written down the general form of a linear differential equation so that you can see exactly what it looks like. The derivatives are written in descending order all the way down to y, and then your coefficients can be constants or they can be a function of x. And then on the right-hand side, you can have 0. That's called a homogeneous differential equation. Or you can have a function that's not equal to 0, and that means that you're going to have a non-homogeneous differential equation. Let's look at an example. This is a linear differential equation. All the derivatives are raised to the first power, and so is y, and there are no nonlinear terms that contain y. It's okay that the right-hand side contains a nonlinear term because that term is a function of x, which is the independent variable instead of the dependent variable. Let's now talk about nonlinear differential equations. A nonlinear differential equation is simply a differential equation that is not linear. Let's look at some examples. In this first example, notice that there is a y squared term. That makes it nonlinear. In our second example, we have a term y times y double prime. This is the dependent variable times its second derivative, and that makes it nonlinear. In our third example, the coefficient multiplying y double prime is sine of y, and this is a nonlinear function, and inside that nonlinear function, there's a y, and that's what makes the equation a nonlinear differential equation. Let's look at some examples where we are going to classify the given differential equation in terms of type, order, and linearity. Let's look at our first example. Let's first classify this equation according to type. It will either be an ordinary differential equation or a partial differential equation. Notice that in this example, we have ordinary derivatives. We have a third ordinary derivative and a first ordinary derivative. So we're going to label this as an ODE. And now let's talk about order. The highest order derivative in this example is a third order derivative. So this differential equation is a third order equation. And now we have to see if it's linear or nonlinear. Notice that the dy dx term is raised to a power of 4. Because it's not just a power of 1, this equation is nonlinear. Any power other than 1 will make it nonlinear. Let's now look at our second example. In this example, we have ordinary derivatives, y double prime and y prime. So this is an ODE. The highest order derivative is a second derivative. So this is a second order differential equation. In this equation, there are no terms with y or its derivative multiplied together or raised to a power other than 1, and there's no y inside a nonlinear function. This is a nonlinear function but has an x inside of it. So this equation we can classify as linear. Let's now look at example 3. Just like the first two examples, this equation is an ordinary differential equation because it has an ordinary derivative, y double prime. So we'll write down ODE. The derivative in this equation is a second derivative, so this is a second order differential equation. And then, because we have a term, y times y double prime, we classify this equation as nonlinear. Let's now look at our last example. This differential equation has partial derivatives. There are 3 of them. Because of that, we are going to label this as a partial differential equation, which we'll abbreviate as PDE. All the derivatives are second derivatives, so this is a second order differential equation. And then there are no nonlinear terms, so this is a linear equation. And that's it. You now know how to correctly classify a differential equation by identifying its type, order, and linearity.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.